Welcome back to the third and final problem of the third experiment, and this problem is on recursion. Recursion is not a wholly new concept. It is actually built on the concept of function. We can call a function anywhere. We can call any function from another function, and we can do it in any ways. We can call even the main function inside of another user-defined function. We can do it. What happens if we call the function in that function itself? Let's say we are building a function that is named as myFunc, and in the function we actually declared this myFunc or call this myFunc again. If this is the case, then we will call it a recursive function. This is a recursive function which calls itself in the body of the function. So it's something like a loop, and if you are using a recursive function, there should be some way to actually break the loop. Otherwise, it will just carry on and on and on if you don't have a condition where the recursion will break. So we have to remember that we have to put a condition at which condition this recursion will break. So that's it. Basically, that's it. So we will solve a problem in this experiment using recursion, and our problem is to determine the factorial of a number of a positive integer. So we will take the input from the user, which is a positive integer. That means it is something from 1 to beyond, and we will actually determine the factorial of it. So let's see how it can be done. Obviously, you all know what is the definition of a factorial. Factorial is basically, x factorial basically means is multiplying all the numbers from starting from x and decreasing one by one up to 1. So that's all. We will do this using our recursive function. So let's go into the code and we'll explain it in there. So this is the code for finding the factorial of a number using recursion. So just an overview of it. The main function here we're declaring two variables of integer type. First one is a, the number of which we want to determine the factorial of, and fact is obviously the result. Then we are writing 2 lines of code to take the input from the user, which is assigned to the a variable, and then we are calling our rec function. Rec function is basically the function which calculates the factorial, and output is set to fact. Obviously, fact is an integer type of value, so the rec should be an integer type of function. So then we are just printing out the value. So our main center of attraction is rec. So let's go to the rec function. I will be writing something down, so let's put the workspace. Okay, so this is our rec function. This rec function takes the input as an integer x. So we have to put some integer here. In this case it is a. This a will be marked or mapped to x. So what happens inside the function? Inside the function you are declaring a variable f. This f is a return variable. The output result will be returned through f. And inside of it there are two conditions. The first condition is if x is equal 1, that means if the input of this function is 1, then we will just simply return 1 as the output. So this is our terminating condition. If the input to the function is 1, we will just simply return 1. There is no recursion in this. It works as a simple function. If the input, if we at some point of the code, if this is our input rec 1, and in that case x is obviously 1, so it will be simply a function which we are using so far, and it will just return 1 to it, nothing else. But the problem is when it is not 1, then it is not 1, else means it is not 1. Then we are calling the rec function itself. We are calling this rec function in this rec function. This is what the recursive portion of this code is. So the line which is used here is f equal to x multiplied by rec of x minus 1. So from this line it goes again into the rec function, and again something is evaluated, and at the end of all this recursion f will be finally returned. So let's see what is happening here. So let's use an example to understand this. Let's say we are trying to determine the factorial of 3. So a is 3. We will call rec of a is 3. So at first it will be the x here will be 3 in this function. So it is not 1, so it will go into the else block, and the f will be 3 times rec of x minus 1. Obviously x was 3, so it will be 2. So it is again going to this rec function, and now again it is not 1, so it will return f is equal to 3 into, sorry, it will be, now x is 2, input is 2, so 2 into rec 1. Now when it is rec 1, then x is 1, of course the input is x, so x is 1 here, so this time it will return 1. It will not go into the x block, it will just simply return 1. So 1 is returned, so this value will be now 1. So 2 into 1, I just erase this thing. Instead of this, I will just write 1 because rec 1 is 1. Now f is 3. F is 2. This 2 will be returned here. So I can just erase rec 2 and write 2. So finally, we are at the first rec function, and this will be simply 6, and this f will be finally returned here. So rec a will be 6. So this is how a recursion function works. I am hoping that you will explore this recursion function more using some practice problems from your book. You can try this one. Try finding the nth number of Fibonacci series using recursion. This n is something that you would want to take as an input from the user, and then try finding the nth number of the Fibonacci series using the recursion function. You will definitely face one recursion problem in your report, and if you get lucky, you will face a recursion problem in your final exam too. Thank you. That's all for experiment 3. Hope you will enjoy the rest of the course. I will not be taking any more videos on this course. So from my part, for all the students of CSE 162, this was my last video, and I wish you all the best for the next part of the course. Thank you.